So we will be talking about Scala here. Initially, I will be giving you an idea of functional programming language. Functional programming. Then we will uh, talk about the functions actually. I will talk about the main things that are required, like function object, function literal. Then we will be talking. I think somebody is not on mute. There is a disturbance. Function literal. Then we'll talk about higher order function. Then few of the higher order functions usually runs on collection. Then higher order functions on collection. So mainly I shall be discussing these things initially. Later, as we progress here, higher order functions on collections are map higher order function, filter higher order function, for each higher order function, and reduce higher order functions. These are the functions I shall be discussing. There is also sort by higher order functions. These functions I shall be usually discussing. And other concepts of Scala we will learn, because these are main important when we want to learn Spark. Other things we will be discussing as we move with the Spark things. So in Spark, as I know, we'll take Spark Core, Spark SQL, which is usually data frames, Spark Streaming. Here I have an use case. In Spark SQL also there is a use case. These two use cases I will be discussing. I have already shown the use case of Spark Streaming. The log analysis demo I have already shown. The same use case I will be completely explaining. Similarly, there is one more use case with respect to Spark SQL. So that also I will be explaining in complete detail. This, this, this is log analysis. This is uh, sessionization. It's a bit of a sophisticated project. Here, Cloudera is being used, Hue is being used, Hive is being used, Spark is being used, Yarn is being used, and Oozie for automation Oozie is being used. So here we will be running multiple Spark jobs. So that's a bit sophisticated project as compared to the other project. Lot of components are integrated here. As we saw here also, lot of uh, components are integrated. So we'll be discussing those things. So just before I start with the Scala here, just wanted to check how many are from the Hadoop background. If there are very few people, just ping yes or no. If you are from Hadoop background, just say yes, otherwise say no. So that I can explain the basic difference between a traditional system and okay. I think Pragati is not aware. Uh, Ramakrishna is also not aware of Hadoop ecosystem. What I will do is just I will give before we start on a Scala, I will just try to give a brief understanding of Hadoop itself. And before we jump into Scala, I will just give a difference or or how do we compare with the Hadoop ecosystem and the Spark ecosystem. Sorry, not Hadoop and Spark. It is just the traditional system and the Hadoop ecosystem. So if we see our traditional system, if I take this is our bare system. Our bare system has servers. It could be CPU cores and RAM is there. If you just take for example a laptop has a RAM and CPU core. If you take i7, if you take i7, usually you will have 8 GB RAM and a 4 core processor. So a laptop is no use if you don't have anything installed on that. If you don't have a Windows or Linux installed on that. So two important things are entities are required for your laptop to be functional. One is the file system and one more is the operating system. Now, what does the file system take care about? It is responsible for the storage here. I can say the disk. Now, what is operating system responsible for? Operating system is responsible for RAM, CPU core, and it is also responsible for scheduling applications. You can schedule the applications using the operating system does that. It will allocate CPU cores and a bit of a RAM for each applications and it will context switch those applications based on your scheduling time and scheduling algorithm. Now you can run any applications on your laptop now. You can run ERP applications, CRM applications, you can some video player. Usually all these Excel sheet, Notepad, MS Paint, all these applications you can run on your laptop. And as you keep on opening new and new applications, more and more CPU core will be utilized, more and more RAM will be utilized, and more and as you increase more applications, your system becomes very slow. The system becomes very slow because you have limited CPU core and you have a limited GB of RAM. So you have 8 GB of RAM and 4 cores. In traditional system, if you take a server also, again it will be limited CPU cores and limited RAM. But if you want to process the data which are as you get more and more data, you have to keep on processing the data that requires more CPU core and more GB of RAM. But your single system cannot. But your single system is limited by the CPU core and RAM. Now, how do we solve that problem? So, how do we solve a problem where your data keeps on increasing? It's the same problem. You want to solve the same, as you can see, your ERP may be based on some DB. This also may be based on some DB. Your applications may be based on some DB. In a similar fashion, analytics applications will also be based on some DB. Now earlier lesser data was there in the DB, so everything used to work fine. So enough CPU cores, few number of CPU cores and few GB of RAM should have been enough earlier. Now our data has increased. How do we handle that? So the one way to handle that is to have multiple systems, not just a single system. You will have multiple systems. So this is just a bare system here. Some system, let's say this system has 32 GB RAM and it has a 8 cores processor. Each system has 32 GB RAM, 8 core processor. On each system, you shall be installing, just like if at all this, if I have installed Windows, if at all I have installed Windows here, so the file system will be NTFS and OS will be Windows kernel. So if at all I have installed Linux, some Ubuntu Linux or any Linux, the file system will be ext4 or XFS is the latest file system. XFS is the latest file system that companies are preferring nowadays. Most of the distributions comes with the XFS file system. ext4 will soon get deprecated. And Linux operating system will be some Linux kernel. Now all these bare system, all this bare system we want to make it work, so we will install Linux here also. In every system we will install Linux. If you install just Linux, so you can use it as an individual system. So here you will have ext4 file system or XFS file system, and Linux kernel will be the operating system. Now if you install Linux, now again you will be using it as a single system. Can we make such that all the system's CPU core and RAM is taken as one system's CPU core and RAM? Can we have that perspective? Can it be treated that all the CPU cores available in all the systems and all the RAMs available in all the system can be treated as one system's CPU core and RAM, so that you get more CPU core, and so can the idea here is, can we treat all these things as one system? From the outside world, this has to be looked as a single system. So if you treat the whole thing as a single system, then you have got how many, you have got lot of CPU cores and lot of GB of RAM. Now if you want to increase the CPU core and RAM, you just have to add one more system to your uh, multiple systems connected together. So how can we do that? So to do that, we have the Hadoop ecosystem. Hadoop ecosystem is nothing but providing whatever was possible on a single system, the same thing we can achieve on a multiple systems. The whole thing will be treated as one system. So you need to have the base ready. What is the base here? Base is file system and operating system. Here also we need to have a file system. Here also we need to have a file system so that it gives the complete disk space of all the system. Let's say the disk is a 1 TB disk. Each system has 1 TB disk. Now we need to have a file system here. We cannot use just XFS file system. XFS or ext4 file system will only detect the disk space available on this machine, on its machine. Here also you will have one more XFS and ext4 file system. It can only detect the disks available on its system. It cannot detect the disks available on other systems. So you want such kind of a framework, such kind of a software or a file system which can detect disks available on other systems also. So it is kind of you want a framework or a file system which can communicate with other system. It should be implemented in the form of a client server model or a master slave model, because there needs to be a communication, because they have to detect disks available in other systems also. So you need a framework or file system implemented in client server model or master slave model. So such kind of a file system is nothing but HDFS. So HDFS, as I said, it is implemented in the client server model or a master slave model. So here master is nothing but called as a name node service, and slaves are nothing but our data node services. So here data node services will be running here. Data node services will be running here, and in one of the node, name node service will be running. These are only the services. When I say services, it is just a JVM process running, a daemon, a long running JVM process. We usually call it as a daemon. So data node are the daemons running on this system. The functionality of this is to detect the disk space available on the system and convey that disk information to name node service. In a similar fashion, every process or the daemons or the JVM process, which are called as data node services, they will detect their corresponding disk space available and they will convey to the master service. Now master service knows that there are in total 1 TB here, 1 TB here is 1 TB here, totally 3 TB disk space. So just like we have our on a single system, just like we have our NTFS or ext4, HDFS is similar to that, but just distributed here because we need more disk space. So this will give us a single perspective that there exists one disk with 3 TB. Even though they are installed in different system, for the end user it gives a perspective that we have one disk with 3 TB of storage space. In a similar fashion, somebody has to also take care of the CPU core and the RAM, just like a OS takes care in a single system. So here the OS responsibility will be, here again it needs to communicate with the different systems so that it can know the total CPU core and the RAM. So the OS also is implemented in the form of client server model. OS also is implemented in the client server model. So that OS is nothing but, in the Hadoop world, it is YARN. Now YARN has resource manager as the master, and name nodes as the clients. So name node, just like data node service is running, name node service is also running here. My mistake. Node manager. Why I'm saying name node. Resource manager and node manager. This is resource manager. So node manager will be your client services. So on every system, node managers will be running. So the idea of the node manager is, the responsibility of the node manager is to detect the CPU core and RAM available on the system and convey that information to your resource manager. Every node manager will do the same thing. They will detect the CPU core and RAM on their corresponding system, and they will convey that information to the resource manager. So resource manager will know the complete information about the CPU core and RAM available on this group of systems. So 32 GB in each system, so which will come to 96 GB RAM, 8 cores, so we have 8 threes are 24. We have just the same system, just like we have a single system with 8 cores on which we have a ext4 file system, or xfs file system, and Linux kernel as the operating system. The only thing is, here we have multiple systems, and all that multiple systems you want to have a perspective as a single system, because you will get a lot of CPU cores and the RAM. If you want more CPU core and more RAM, you can connect one more system to the network. All these will be in the same subnet. You just have to connect one more system to this network, and a data node service will be start running there, and node manager service will be running there. They will also convey the disk space, and they will also convey their CPU core and RAM here. As a result, so it will become 4 TB disk, then 32 more here, 140, 140, right? 126, 128, 128 it will be, and this will be 8 more, which is 32. So you are increasing your CPU core and RAM here. Hadoop is all about making your multiple systems to be, I mean, making the resources available on multiple system to be showcased as a resources available on a single system. For the end user will be only connecting to these two services. So end user will be only connecting here. And name node will say that I have got 4 TB of disk, and resource manager will say that I have got 128 GB RAM and 32 cores. So that's the idea of the Hadoop ecosystem, providing multiple CPU cores and multiple GB of RAMs, and also a multiple disk storages. Now on top of this, you have just got your file system and operating system ready. Now you can run applications on top of this. The only difference is Hadoop ecosystem is not designed to run ERP application, or CRM application, or any web application. It is not designed for these. Hadoop ecosystem is designed for processing your data and doing analytics. The thing we used to do in the data warehousing, such kind of a things is is done in the Hadoop ecosystem. You don't play any video player, you don't install any video player or Excel sheet, MS Paint. Such kind of a things is not the Hadoop ecosystem was developed for. Hadoop ecosystem was developed for the analytics of the data that we will be going through in this training session. So I hope Ramakrishna and Pragati, you got an understanding of what is Hadoop here. So I will just put some more things for the understanding sake here. So you have your file system. HDFS is your file system. It is called as Hadoop distributed file system. So you have your operating system. I mean, usually nobody calls it as an operating system. Whenever people say about Hadoop, any new releases comes in the Hadoop, it means that new releases are associated with the HDFS and YARN. Hadoop new release means it is all about your file system and your operating system has been upgraded. And nobody calls it as a OS. I just use that word so that I can compare it with the traditional systems. Usually it is called as a cluster manager. So cluster manager means which manages the resources of the cluster. That's why they call it as a cluster manager. Yarn is a cluster manager. Or for better understanding, you can imagine it to be just like an operating system which will allocate CPU cores and RAM to different applications, and it will also schedule the applications. Now here the applications that will be running are not these things, but instead it will be analytics applications like Spark application, Hive application, Pig application, the Scoop application, MapReduce applications. These are the applications that we will be running on this systems, on this Hadoop system, which are mainly used for ETL processing, data warehousing, and analytics case. So that's the problem statement it tries to solve the Hadoop ecosystem. So if you want to process the data, we know that we have we have MapReduce. We already have our file system, so you can copy the data to the file system. You can store the data in the file system. Now you need some applications to process that data. To develop that applications, again we have the MapReduce framework, which usually is under the Java framework, or you can write Python code, or you can write some other code, C++ code, other traditional code you can write to implement applications using MapReduce, because MapReduce exposes only a traditional programming language to write the code. So if you want to do some more processing, suppose if you, we know that Hadoop is now used for data processing. Now inside a company, they have a data warehousing team, and they want to move from the traditional system to Hadoop system. Now most of the people in the data warehousing are SQL experts. They are SQL experts. Now making the SQL experts to learn traditional language so that they can write MapReduce program to process the data is not a feasible solution. As a result, one more framework was introduced called Hive. Hive framework was introduced. It is just a framework. It is just an interface framework. It is not a database. Most of the people have a impression that Hive is a database. Hive is not a database. Hive is just an interface framework which gives the end user to write SQL kind of queries, which will be finally transformed to the MapReduce applications, which will read the data from the file system and start processing the data. That's the idea of the Hive. In a similar fashion, for ETL processing, instead of again learning traditional languages, instead of learning traditional languages, they have introduced one more framework where you can write scripting kind of a language to do the data processing. So this is SQL kind of language. This is scripting kind of a language, just for data processing. So you can think of Spark come somewhere here. Spark is in parallel to MapReduce, or it will going forward, it will replace the MapReduce. Instead of using MapReduce as a processing framework, we can use Spark as a processing framework, which is much faster and leaner than your MapReduce. I will stop it here. I will stop it here for the Hadoop introduction, because as in we move forward, we will be discussing more and more stuff on this. This was just to give a brief introduction on the Hadoop ecosystem. So I hope till here things were clear. Any questions are there, you can ask. Anytime any questions you have, you can always ask the question. So if there are no questions, we will start with the Scala part here. Now the very first question arises: what is functional programming? Any guess on anybody from probably few people may already know that what is a functional programming. Just give your understanding. You can share your understanding on what is functional programming. Anybody has an idea on functional programming? What is functional programming? So functional programming is here every operation is considered as a function. Yes, we can say that. We can say that actually that is a result of a functional programming. That is a consequence of a functional programming, making every operations as a function. So I will take a slight example, not to worry about the syntax here. Later we'll be understanding the syntax as well. So you have to just, so if you install my image, you will get this, Ubuntu system. You have to just click on the terminal. Once you click on the terminal, just type Scala there. Scala is already installed. You just type Scala there. So I will just define something, and don't worry about the syntax because we will be learning about the syntax. So here what I will do is I will define some variable as g is equal to 0 here. G is equal to 0. Then don't worry about var and all, we will explain those things. Then I will define a function called called something, some function. The name of the function is, this is how you define a function: def keyword, function name. It takes an input, say let's integer x. Don't worry about the syntax. So I will just say something. I'm just writing something here. Now this is a simple function. This is a simple function here. It doesn't do anything. To that function we are passing some parameter. It is that parameter value is being assigned to g. I mean it is incrementally assigned to g. Then we have defining some local value, and we are returning that local value. Not any complex thing, simple arithmetics we are doing here. Now let's call this function by passing the parameter as any value you pass it here. Let's say 5. So when we passed 5, it returned 7. Again I will call it with the same value 5. So I got totally different return value. So keeping this in mind, I would like to explain what is the functional programming. Functional programming is all about avoiding mutability and having pure functions. So different ways to look into it. Functional programming is avoiding mutability, writing pure functions. All are interrelated. Have a clear cut differentiation between have a clear cut difference between mutability and immutability. So usually we say it as a functional. So the idea is to make safe all these things. The goal of functional programming is to make your code safe. Is your code safe? So we achieve a greater safety with functional programming. Now, before we go that, what are all these things? What is avoiding mutability? What do we mean by writing pure functions? So what do we mean by how clear-cut difference between mutability and immutability? These all things looks to be strange. What are all these things? I hope here we know what is mutability and immutability. Mutability is modifying something. Immutability is not able to modify something. So that's what we call as mutability and immutability. You can modify is mutability. You cannot modify it is immutable. So if you take this example, if you take this example, this function is not a pure function. This function is not a pure function because it modifies some external entity which is in the scope. So this is the external entity which is being modified. So if I say now get the value of g here, g is as of now 10. G was 0 earlier, now it is 10. Now today we execute this code. Today I have written this code. So I may not be surprised that G value will be changed. So tomorrow somebody else will execute this code. So obviously they will be surprised to see that what is this G and why this G is getting modified. So it is trying to modify its surrounding. As you can see is it is trying to modify its surrounding. So this is not a safe function. I mean, let's say you take this function and run it somewhere in a totally different context. If at all in that context, if there exists any G in that scope, so it will modify that G. So obviously this function is not a safe function. I hope I'm able to convey the things here. I'm able to convince that this is not a safe function. So today I have written this code, so it will modify its surroundings. Whatever is there in the scope, it is modifying. If I take the same function and run it somewhere, and in that context, in that scope, if something called G exists, a G variable exists there, obviously it will modify that also. So the people there will be confused why this G got modified. So that's the reason I'm saying that this is not a safe function, because this is not it is not sorry, it is modifying its surrounding, it is doing some side effects. So such functions are not called as pure functions. A pure function is a function which does not modify its surrounding. its surroundings, we can say. Just uh, formal terms I'm using here. Usually nobody will use that formal terms. Just for understanding I'm saying here. So if you write, so such kind of following such things is all about functional programming. You are you are avoiding the mutability. You can also think this as a global structure. Anything outside of this function is global to this function. So you avoid modifying such things. You avoid modifying such things. That's what the first statement is all about. Avoiding mutability. Now avoiding mutability is not a, you don't have to keep it in general. It is all about avoiding mutability of your surroundings. That makes your code safe. You can take that code and run it anywhere. So just for an example, so there is a square root function in the math library of Scala. So it just gives the square root. As you can see here, this is a pure function. This is a pure function. It doesn't do anything on the outside world. Will it not be safe to take this function and run it anywhere? Because it will not modify any of its surroundings. So this is kind of a pure function which will not modify its surroundings nor the internal things. So every time you give value as 16, input is every time you give the input as 16, every time it will give the value as 4. So nor the internal things are modified nor the external things are modified. It is a pure function. It is safe to take this function and deploy it anywhere. It will give the same result for the same input. So if I call our modify with 4 here now, it keeps on returning different value. Earlier it returned 12, before that it returned 12. It also does not give the same value for the same input. Again if I pass 4, it gives a different output. Again if I pass 4, it gives a different output. It is not like our square root. Square root for the same input, always you will get the, so it is a safe. So the main idea is to avoid mutability. So here we are. Here if you write a function which takes the input and does not modify its surroundings or anything else, it is a pure function, and writing the program in this fashion is called functional programming language. It's all about avoiding mutability. It's all about having a clear-cut difference between mutability and immutability. This we will come into picture. These things, the third part, I will explain this. But I hope you got an understanding of what is functional programming. Just imagine it like avoiding mutability. When you avoid mutability, your function becomes safe. You are writing a pure functions because of which you are avoiding mutability. When you avoid mutability, your function becomes safe. You can take it and run it anywhere. In any context you can run it. You will be sure that it will not modify its surroundings. I hope you got the idea here. I hope I was able to convey what is a functional programming here. As there is no questions and no acknowledgement, I assume it is clear. I got an acknowledgement. I hope the same acknowledgement is from everybody. I assume it is clear. It would be good to get a acknowledgement so that I can, whether I have to repeat that or should I go ahead. Okay, thanks, thank you. And how do we avoid mutability? Now this function is is doing mutability. Now how do I avoid mutability? How do I avoid mutability? So I define a function called modify. It will be slightly different. We take some input data, we process input data, and we return processed data. Forget the program that I had written in the Scala console. Just concentrate on this. Here what we are doing is we are taking some input data to this function. We are processing that input data, and finally we are returning the processed data. So this I will say we are avoiding mutability here. This function is avoiding mutability. The question arises, how can I say that this function is avoiding mutability? Any guess on why this function is avoiding mutability? Even though I have written, so it puts in a dilemma. Let's say it is some ABC. The function name is ABC. ABC takes an input, processes that input, and it returns the processed data. Now this is not a complex function, a simple function. Now this function, I am saying that it is avoiding mutability. Since it is avoiding mutability, I can say it is a functional programming style. Since it is avoiding mutability, I can say it is a functional programming style. Now what is avoiding? How can I say that this is avoiding mutability? Right. It's almost the same thing. It is not. So I will put everything in one context, saying that it is not. So to make that understand, most of the answers are correct there. Most of the answers are correct. So let me explain in a different way so that it is more understandable. So what we are doing is we are taking some input data, we are processing the input data, and we are returning the processed data. So here this return is the one which is making this function to avoid mutability. Return statement or return keyword is making this function to avoid mutability. How can I say that? How can I say that because of return we are avoiding mutability? So to prove that, we will take the reverse of this. What we'll do is we will not return anything. What we'll do is we'll not return anything. And we will prove that if we don't return, we will modify something so that the converse becomes true. Converse becomes true here. So we have our input data now. This function takes the input data. It processes the input data. It processes input data. And after that, nothing. We are not returning anything. So if when you come out of this function, if the execution comes out of this function, all the process data is lost. All the process data is lost because we are not returning the processed data. We are doing nothing with that processed data. We are just coming out of this function without doing anything. We are just processing, and as soon as you come out of this function, all the processed data is lost. Now, then there is no use of this function. This ABC function, there is no use. Now, what is the only other possible thing we can do so that this processed data is not lost? What is the only other thing that is possible? I mean, what is the other possibility? What other possibility we have other than returning? What is the other possibility that we have so that this processed data is not lost? The other possibility that we have is we can save this processed data to some global structure, global data structure. We can save it to some file. We can save it to some DB. We can save it to some message queue. So that's the only possible way we have so that we don't lose this process data. Now, what are all these things what we are doing here? We are doing mutability here. We are modifying our global data structure. If at all we save it to a global data structure, we are modifying our global data structure. If we are saving it to the file, we are modifying the file. The file had something earlier, we are modifying that. We are modifying the DB if at all we save it to it, or we are modifying the queue here. So if we don't return anything, if we don't return, the only possible way is to do some mutability. To retain that data, the only possibility we have is to do mutability. So if we return this, we avoid doing this mutability. We avoid doing this mutability. So that's the way you avoid. You take the input data, you don't modify anything in its surroundings, you just process it and return your processed data. That's all about functional programming language. So our square root function, if you take, it doesn't do anything. It takes the input data, it computes square root and just returns that. That's the idea of functional programming. That's the idea of functional programming. Here also the same thing. So you can say that I will call the save function here. I will call the save function here. Then I will return the processed data. Obviously nobody can stop us from doing that because we can write any program. We can write the program to save, and we can write the program to return. First one line will write to save, we will just make a call to the save method, and we'll also make a call to return it. Just two lines of code we have to write it. But that is not recommended actually. So that is not recommended. So if you want to save the data, write a separate function. If you don't want to save the data, write a separate function. Do these two things in two different functions. You should not put these two things together, because if you this function becomes unsafe now. If you take this function and run it in somewhere else, it may modify something in that context. So what you have to do is you have to write a separate function for mutability, write a separate function for immutability. So that is much safer. So that's the third point I wanted to discuss here. Have a clear-cut difference between mutability and immutability. Write separate function for mutability and separate function for immutability. So I mean, all are interlinked. Most of the things are interlinked. So you can just think of saying functional programming is all about avoiding mutability and making your function safe, so that when you run that function in different context, it doesn't modify its surroundings. So that's the bigger picture of functional programming. That's the bigger picture of functional programming. And Scala is functional programming language. Scala is functional programming language and and pure object oriented programming. Scala is both actually. They have taken both the good things from functional programming and object oriented, because object oriented programming is also a necessity. You just cannot avoid object oriented programming. So when you put these two things together, you get a good language. And Scala is functional programming language and a pure object oriented language. And in most of the distributed processing, what we do here, I mean, here I was saying that if i if I take this function if I take this function and run it anywhere, it will be a safer function now, because we are avoiding mutability, we are achieving immutability here. So this is a safer function. Now if you run this function anywhere in any context, it will be safe. We are guaranteed that it will not modify its surroundings. And that's what happens in the distributed processing. Your function will be running in different systems in different contexts. So if you want to make your function to be safer, so you usually go with the functional programming style. So functional programming style is suited for, that's the reason it is suited for distributed processing or distributed programming or distributed processing. Since functional programming is suited for distributed processing and Scala is a functional programming language, as a result, Scala is in demand in case of distributed processing. So that's the reason Scala is getting more and more demand in case of distributed applications, because functional programming is more suited for, is safer, we can say, in case of distributed processing. So I hope these points were clear on a theoretical level on how the things work. Why why functional programming and why Scala is being used in demand, why functional programming is in demand. So all those things, I hope it is clear. So what we'll do is we will wind up the session here with these things, because from tomorrow I will start with the Scala as I discussed. The actual programming we will start with, and before I start with, I want everybody to be ready, or if if you could send me your email IDs to my email ID, I will share all the three. I will share the documents as well as the image, so that from tomorrow you will be ready for the hands-on. So shall we wind up? Don't forget to send your email ID. Otherwise, I won't be able to share the Google Drive. Please do share your email ID. So shall we wind up here with these things? From tomorrow, it will be we will continue with the Scala part. Thanks everybody, and have a nice day and good night, others. Sure, I will be uploading the video